recording, share screen. Okay. Can you guys see where it says lesson 3 radians? Or no?
Lesson 3, we're on radians and reference angle notes.
Yeah, can you see it?
Yeah.
Oh, okay. All right. So we're going to work more with radians, and it's helpful to have an idea of some common angles. So I've got a circle here. Of course, we put angles on a XY coordinate system. And I got a circle here with, we're going to fill in with our common angles. And we're going to do it first in degrees, and then we'll go through and do it in radians. So right there is just 0 degrees. This is 30. This is 45. This is 60. That's 90, of course. And then 90, this would be 120, sorry, 135 degrees and 150 degrees. So those two lines divide that quadrant into thirds, okay? So 30, 60, 90. And then these two lines divide that quadrant into thirds. So it's every 30 degrees. So we go from 90 plus 30 is 120, plus 30 is 150, plus 30 would be 180. Okay, and then the line, so the same thing, this line and this line will divide it into that quadrant into thirds, and those two lines will divide those quadrants into thirds. So 180 plus 30 is 210, plus 30 is 240, plus 30 is 270, plus 30 is 300, plus 30 is 330, plus 30 is back to 360. Okay, now these lines divide the quadrant into 45 degrees. I mean, yeah, so like it does half of your right angle. So that's 45 degrees. So 0 plus 45 is 45. 45 plus 45 is 90. 90 plus 45 is 135. 135 plus 45 takes us to 180. 180 plus 45 would be 225. And then 225 plus 45 is 270. 270 plus 45 is 315. Okay. So those are the common degrees, and you're going to want to get pretty familiar with this trig circle. We want to go through and fill in radians. So I'm going to do radians here in a different color. So 0 degrees is also 0 radians. And we know that 180 degrees is pi radians. Okay. 90 degrees is exactly halfway between 0 and pi. So that would be how many radians? Folks, can we turn on our cameras, please? So that would be how many radians? Zoe, what would 90 degrees be in terms of radians? If 180 is pi, then halfway would be?
It'd be pi over 2.
Yep. Exactly. All right. So every 90 degrees is a half pi. So 0, 1/2 pi, 2/2, which is a whole. Down here would be what, London?
Wouldn't it be negative pi over 2? I'm not sure.
Well, we could do it as a negative, but right now I want to do everything as a positive angle. So if we think about how every right angle, every 90 degrees is a 1/2 pi. So 0, 1/2 pi up here, 2/2 pi,
3/2 pi.
3/2 pi. Okay, and then 3/2 pi, this would be 4/2, but 4/2 is really 2. Okay, so if halfway around is pi, then the whole way around is 2 pi. How are we doing so far? Sophia, are you there?
Yeah, I am. I had to move up to my room because like my parents were just being really loud.
Okay.
Yeah.
Okay, so can you turn your camera back on then?
Yeah.
Okay, great. All right, are we doing okay with this so far, guys?
Yeah.
Okay, so so let's do the 45 degrees. So 90 degrees is pi over 2, 45 degrees is half of that. So half of pi over 2 would be pi over 4. So 45 degrees is pi over 4. Okay, so if I count by 1/4 pies, all right, so here's 1/4 pi. Every 45 degrees is a fourth of a pi. 1/4 pi, 2/4 pi, which is 1/2. What would this be, Carolyn?
Did you say me or Lynn?
I said Carolyn. Yes, you.
Is that pi over 3? No. Is that 3, pi over 3? Or is it?
Okay, so this is 1/4 pi, 2/4 pi. I'm counting by 1/4 pies. Every 45 degrees is a fourth of a pi. So this is 1/4, 2/4,
3/4.
3/4 pi. Okay, then 3/4, then 4/4 pi. Well, 4/4 pi is pi, right? 4/4 pi, what would this be down here? Matt?
Sorry, 1 1/4.
Okay, we're going to write it as 5/4 pi. We don't do mixed numbers with radians. We always do an improper fraction. Okay. Yeah. So that's 5/4 pi. Down here would be 6/4 pi, but 6/4 reduces to 3/2. So 6/4, and then what would this be, Luke?
Did you say the one before was 6/4?
Yep.
So this would be 7/4.
So this would be 7/4 pi, and then 8/4, but 8/4 is 2. Okay, so does that make sense how we just counted by 1/4 pies, guys, going around every 45 degrees? Okay, now we're going to do the yellow ones that divide it. Remember, that divides each quadrant into thirds. So first of all, we need to get what 30 degrees is. How many radians would 30 degrees be equal to?
Would it be pi over 5?
How would you get that?
Well, it seemed like pi over 4 was like 2 away, so I just went one more. I'm probably wrong.
Okay. Yeah, it's not that. If we think about the 30, let's look at the 30 degrees. How many times does 30 degrees go into 180?
6.
6. So if 180 is pi, then 30 degrees would be
1/6.
1/6 pi. Okay. So, so that's 1/6 pi. Every 30 degrees is going to be another 6. So this is 1/6. So here I'd be at 2/6 pi, but 2/6 reduces to 1/3. So this would be pi over 3. Questions about that much so far, guys? I use the fact that 30 degrees is a 6th of 180 to figure out this is pi over 6. Now I'm going to count every 30 degrees is another 6 pi. So 1/6, 2/6, which is a third, 3/6, that's a half, 4/6, 4/6 reduces to 2/3 pi. All right, that's 4/6, 5/6, 6/6. Well, that's just 1. Okay, so what is this? What's this going to be down here, William?
7/6.
Thank you. 7/6 pi. This is going to be what then? Simon, what's the going to be here at 240?
8/6.
But does that reduce?
2/3.
8/6 is 4/3.
Oh, okay.
Okay, so that was 8/6. 9/6 is 3/2. 10/6. What does 10/6 reduce to? 5/3. All right. 11/6. So here at 330 degrees, it's 11/6 pi. And then here we'd be at 12/6, which is 2 pi. Okay. So you might want to highlight or notice, let's see. Does that work? So pi over 6 is here, and 5/6 pi is here, and 7/6 pi is here, and 11/6 pi is there. That's where all the 6s are. Okay. One way to think about it is they're 30 degrees. If you look at this axis, the x-axis, they are 30 degrees off of the x-axis. 30 degrees up is 1/6. 30 degrees up here is 5/6 because I'm just 1/6 away from a whole pi. 30 degrees down is 7/6 because that's a whole pi, 6/6 plus 1 more. And then this one, if I think about 2 pi is 12/6, I'm 1/6 pi short of that, so I'm 11/6 pi. So the 6, all the 6 are the ones that are closest to the x-axis. And then, let me see, let me do these in green. If we look at the thirds, okay, that's where all the third pi's are. Notice they're the ones closest to the y-axis, right? They're closest. If I go off of the y-axis, the first thing I hit is a third. So you're really going to want to spend some time looking at these patterns and trying to get this kind of figured out, that you could fill this in pretty quickly with both degrees and with radians. Okay, I think we've got about 10 minutes. All right. Of course, the force, there's the force. All right, they're obviously right in the middle. That one's doesn't look very good. They're right in the middle of each quadrant, okay? All right, questions about that, guys? Do you see where all of that came from? Okay. All right. Show each angle in standard position. Then name two angles coterminal with the given angle. So we want to try to start thinking in terms of radians. It's kind of like learning another language. You want to think in that language. You don't want to always be translating. So we want to think about where these angles are. Name two angles coterminal with the given angle, one positive and one negative, and sketch those in. So pi radians, I think we've worked on, that's 180 degrees. So that's a straight angle. I want another angle, like I could go this direction and end up at pi as well. What would that angle be in terms of radians, not degrees? What would that be? Joel, what do you think that one would be?
I'm not really sure.
Okay, so would it be positive or negative?
Positive?
Okay, so positive is always going in a counterclockwise direction. Negative is when you go in a clockwise direction. So it will be a negative angle. Okay, and it's a straight angle. So a straight angle is pi. So this is negative pi. Okay.
Yeah.
Okay, another way I could end up there is I could do a, well, dang it. Sorry. I could do a full rotation and then another half rotation. What would that be in terms of radians, guys?
Two pi.
So the full rotation is 2 pi, and then I do another,
So 3 pi.
so it would be 3 pi. That's exactly right. Does that make sense, folks? What's a full rotation? A full rotation in radians is 2 pi, right? So just like in degrees, I would add or subtract 360 because that was a full rotation. For radians, if I want a coterminal angle, I can add or subtract 2 pi. So I could look like this one is like pi minus 2 pi gave me the negative pi. Pi plus 2 pi gave me the 3 pi. So the angle that I started with was pi. And then I added or subtracted 2 pi to get a coterminal angle. Okay, let's try another one. So 2 pi, I know, is a full rotation. Well, what if I started and went in the opposite direction and still wanted to end up there? What would be the measure of that angle in radians? Mackie?
Would be 4 pi, or since you're going negative, then 0 pi?
So it is negative. Did I just turn 0 radians or did I turn?
Oh,
I turned,
no.
so it'd be
Right.
negative what?
Negative 4? Or
Well,
negative
negative, it's one rotation, so it's negative 2 pi. If 2 pi is one rotation, 4 pi would be 2 rotations.
2? Yeah.
Yeah, okay. So I could also do a full rotation and another full rotation and still end up there. What would that one be? Sophia?
would that be, is it still a negative or?
No, I went in
Oh,
the
wait, yeah.
positive. I just did 2 rotations though. Here I did 1 rotation, here I did 2.
Would it be 4 pi?
It would be 4 pi. Yeah. So again, a full
You're frozen, Miss Armada.
Oh. Am I still frozen?
You're frozen, Miss Armada.
Okay. Am I still frozen?
Yeah.
Okay. Can you hear me now? Oh, dang it. All right. Can you guys hear me now?
Yeah,
Okay.
Yeah.
I can hear you.
I just got kicked off my Zoom. It stopped sharing, and so we're done for today. How's that? We're tired of technology. So folks, let me look at the homework real fast and see what I want you to do. Ah. Okay, here's what I want you to do the first 2 pages of the homework. Okay, the first 2 pages, because we didn't get through everything. I'll email that to you too. You don't hand anything in until we get the whole homework assignment done. Okay, and I'll send you out an email to make sure everybody knows what's going on. And you guys have a great day. I will see you Thursday.
Thank you.
Bye.
Sorry, Moto. What time does academic flex start again? I'm sorry.
12:10.
Okay. Awesome. And then if you need time to just if you want to start a little bit later, that's fine. I don't know what kind of schedule you have. I'll just plan around you.
No, 12:10 works great. And the link is on the Google Classroom page.
Okay.
Okay, thanks, Matt.
Thank you. Have a good day. I'll see you
You
soon.
too.